All right, welcome to Monday, week two, for this. We'll do a quick announcement. As far as computing activities and careers and stuff like that, this is a busy week. Week two is where we get a lot of stuff done here. Tomorrow, DigiKey, a large employer, is going to be on campus at noon. To 1 o'clock, and buying pizza. Sorry, again, it's mainly for second year students and above. So it's if you're in Dignitas, you may not be able to attend, but if you can attend that, it's a great experience to learn about this employer and the jobs they offer and get free pizza. Wednesday is the experience fair. Lots of opportunities. I'll be there tabling for Ireland. I'm one of the faculty doing the Ireland program this year. In the spring. So the different study abroad opportunities, volunteer opportunities, and stuff like that. And experience fair Wednesday night is the club crawl. The Tech and Innovations Club is the computer related club. Ariana is the new president of that club. And that's a very student-driven club. A lot of times what they're doing depends a lot about what students want to be in that club that year and what they want to do. So consider joining that club. It's fun to figure out what you want to do and that sort of stuff. Thursday is the first of our big career fairs. Often they are at the universities and often at UMD, and we have agreements with UMD so that all of our students can participate too. So STEM Fest is the career fair 10 to 2 over at UMD. There'll be a shuttle bus running from campus here over to there for that. There's like 100 employees or employers there. They do target a lot of engineering programs, but there are quite a few companies that will be hiring computing students there. DigiKey, of course, will be there. That's one of the reasons I'll also be on campus is they'll be interviewing. So they'll be interviewing on campus on Wednesday, but here, and then they'll be at the career fair on Thursday, the STEM fair there. Essentia Health, the big hospital system in town, is there. Federated Insurance in Owatonna. They just hired our grads last year. They're looking to hire some more computer students for internships there. And Securian Financial is a big financial insurance company down in St. Paul, and they've always been high. Well, we're in the Securian lab right now, so that can tell you how important Securian is to our students. So those are some of the companies that will be there for things. So consider going over to the STEMFest for that. And even as first-year students, it's good to just go over there, even if you don't have a resume or anything to hand out, just to talk to people about the jobs and get names, because what's hard is when you're like a junior and want an internship and you haven't even heard of these companies, and you have to walk up and go to a company and go, well, I've never heard of you. Tell me what you do there. And not a great first impression as a junior, but as a first-year student, you can do that as many times as you want to know. I'm a first-year student. I'm just learning. Tell me what your company does, and you can use that opening line again and again for these companies, and pick up their free stuff and talk to them about it. And this is a good time to do that sort of stuff. And you don't need to have a resume or anything yet if you don't want to. And again, some of them have internships. I know like DigiKey. And I think Federated and Securian all are really targeting third year students there. But again, it's not to say that other ones like Essentia Health and Anderson might be hiring. And St. Louis County, I think, is hiring. When they do an internship, it's open to more people. Okay. So what are we going to do this week? So we have week two. I just noticed I didn't open up week two until this morning. I usually like to open up over the weekend. So if you're bored, you're sitting home bored over the weekend. Oh, I'm home bored. I wish Tom would open up Java so I could look at it over the weekend. And I didn't. So I'm sorry I ruined your weekend. there. I'll try to do that better in the future. There. So we're doing unit 2, kind of a standard unit. So on Mondays, I talk a fair amount. We'll do some activities, do some programming, but it'll probably be half the time me talking, half the time you programming. On Wednesdays, we'll do the learning activity here. We'll do Mad Libs, and you'll post that to the discussions there. And I think I'll probably break you in pairs again on Wednesday for that. So on Wednesday, we'll do whatever is required for the discussion, and sometimes we'll call that a learning, a lab or whatever there. And then on Friday, we'll work on the review problems, these practice problems, and work on those. And in the end, if you want to work on your assignment, you can work on the assignment also on Friday. So we'll start here. We'll just go over the learning material, go over the textbook material, that sort of stuff. Learn the new material, kind of cover the new material, practice it a little bit, and then we'll do more stuff, more applied stuff with the Mad Libs on Wednesday. And then by Friday, hopefully you can be working more on your own on the assignment and the practice problems here. So let's jump into the learning material. So we have to start talking about variables today and how variables work and store information for this. And again, you have a kind of choice of which of these textbooks, free books to do. I'm going to open up the CS Awesome one. I think I'm also going to open up the Intro to Programming one here and look at that. So let's talk a little bit about these stuff. So again, we're going to want to be storing information in our computer, and we're going to use variables for that stuff. And so you can imagine a variable as an area memory where we're going to store, like a box in memory where you're going to store something, and a label. I often think of it as like, I don't know if you organize your stuff, but if I go into my storage, my utility closet at home, I have bins, and then I'll have labels on the bins for what's stored, and I'll have different size bins for different things in there. So I have some small bins to store little things, some larger bins to store larger things there. So there'll be different size bins that I'll store stuff in, and then I'll have names on the different bins for what I'm storing in there. So that's kind of what variables are. There are different size variables for storing different things there. Is this a big thing? Is it a little thing there? And we have names. Now, the names are somewhat, have some rules in them. And so like this textbook talks about some rules. So you can have just like N or X as a variable name, although we'll prefer longer names like rate or something like that. They can mix uppercase and lowercase. They're case sensitive. So like hello world, all lowercase is different than hello world with an uppercase H and an uppercase W there. You can have underlines in the words. So you can have quite a long name here for this stuff. We will tend to prefer meaningful names. So we don't want to just have variables like X or X1. Generally, we'll want, if we're storing someone's name, it should be name or user's name or L name or last name or something like that for those variables that we do. There are some reserved words that we can't have like class or static or if there. You can have those part of a bigger name. So you could have class project as a word, but you can't have class by itself here. And every once in a while, sometimes people accidentally use a reserved word and the computer will get confused about it. But there are not that many reserved words for this. So with this stuff. So again, we'll be doing these variable types. We will tend to use that variables with something called camel case. I don't know if you've ever heard of, you certainly heard of lowercase and uppercase. Camel case means that we start with lowercase letters, and whenever we get to a new word, we go uppercase. And if we get another new word, we go uppercase again, and then it finishes all lowercase. So it's kind of like a camel with humps in the middle of the word where the upper, that's just what it's called, the camel case there. A lot of companies have that as a standard requirement for naming variables in those. We'll talk more about rules right away. I don't want to throw a lot of hard rules at you for programming, but in a couple of weeks, we'll talk about more and more kind of guidelines or coding standards that companies often have. Okay, so we have these variables. We declare these variables. They have to be of certain type. So for something. So we'll say things like, we'll have a couple of standard types. Int will represent an integer, positive or negative. Double will represent a decimal number here. Now, why is it called double? Well, there's what is called a floating point number, which is what is a decimal number, but it's not very precise. So double is a double precision floating point number. And nowadays, everyone just uses double. No one uses these floats there. And so the old word is still there. It's double. So that's double precision floating point number, or basically, so you just have to learn to associate double with decimal here. It actually stores it more like in scientific notation. It can be really large or a very small decimal number. Boolean is a variable that's either true or false. So again, these other variables, like you're used to doing math with, you can think back to algebra where you said, you know, x is equal to 47, y is equal to x plus 2. We kind of used to maybe that sort of thinking with math and numbers. Boolean is something that is either true or false, and it takes a while to get used to Boolean variables in a variable that can hold either true or false there. But there are some reserved words, true and false, in Java that we set this to, or we can test it against. So we'll also look more later on at characters, a single character, and strings. But we will talk a little bit about strings now because we want to be able to input a string or work with strings. So a string will be a series or a string of characters, letters there. It can be someone's name, like, you know, it could be a string, but also like their phone number or something like that. So a date can be stored as a string. So lots of stuff can be stored as a string there for us. So just any string of characters that we want. And we'll put them inside double quotes for that. So, and again, one thing I like about CS Awesome is they do have these little self-checks. So, you know, what type should you use to represent the average grade in a course? So you're thinking average grade like, you know, 4.0 or 3.5, but average, like your GPA is actually, you could be like 3 point something, or, you know, 2.7, something like that. So that's a decimal. So it's a number here, and it's decimal. So I'm thinking it has to be a double, and I can check, and I get my yay, you got it right. Purple check mark, which I like. So, now, once we get into this stuff, we'll be declaring these different types. And again, here's the other textbook talking about this. Now, if you've programmed in other languages, like particularly Python or JavaScript, those are what are called are weakly types. So you can declare a variable and not have to specify what type it is, and the computer will figure out what type it is depending on what you store in it. But in Java, we have to specify the type of every variable there and be very explicit. We can't change the type as we go. So if we say this is an integer, And later on, we're going to want to try to store a decimal in there. That will not work. Once we say this is an integer, we set aside that box in memory, that size box for an integer in memory, give it a name. Later on, we can't stick a string in there, or we can't stick a decimal in there, because decimals are different size than ints inside the computer. A string of characters is different than a decimal. So we're really stuck with, so we talk about these strongly typed languages here for this. And again, that's if you've programmed in some other languages where you don't worry about the types, this kind of strange that you have to specify that. So there are a lot of types, and again, we will ignore a lot of these there. So there's byte and short and long and double and float and stuff. And again, they talk about that. Like, there are just 3 different types of integers. There's a short, which is a little integer, an int, which is a bigger integer, and a long, which is a very long integer. So, short can go from up to 30, minus 32,000 to plus 32,000 there. And int can, 2 billion to plus or minus long is another thing. We used to worry a lot about these because, like, if you're going to make an app for your phone or for some device, we even for computers back in the day, there wasn't much memory, and you had to be very particular about the memory that you're programming to. But nowadays, memory is really cheap generally, and a lot of things have that. Unless you're programming like for your watch or some device like that, that might have a small, even your watch has a lot of memory nowadays. But even a watch or some little device like that, you might be worried about, oh, I should use a short instead of an int there. But we are not going to worry about that. So we're going to stick with ints and doubles as our numbers for that. So, okay. And again, some of this talks about strings and stuff, and we're going to save some of the string details for later here. So let's try to program some samples here. Now, Chris Gleasner is the chair of our department, and he's recorded a couple of videos that walk you through this stuff. And so if you get tired of me explaining these, you can listen to Chris explain these to you also. And he has some nice diagrams and stuff that explain these stuff, walks you through some of these textbooks and stuff like that. So Chris has some good videos here that you might find useful here. So those are linked in under each learning exercise. And they're not for that. He generally walks through some of these examples. We're going to look at this first example, variables. Oh, yeah, fire alarm test today. You're supposed to say, yes, didn't you read the memo? There's a fire alarm test today, right? Yeah, there's a fire alarm test at 12:04. So, okay. Typical drill, you've done this. You probably haven't done it in here, but you've done it before, right? So we just have to get up, go outside. It's going to be a little cold. You have your jacket. We'll come back here. So grab your stuff. We'll go outside and stuff like that. So, yeah. Okay. So go outside. Go out one of the front doors. Stand out there. Visit. They'll tell you when to come back in. Okay? I'll be with you in just a sec. Follow Chris. I think I will go check. It's not a drill. I'll come back and get you. Okay? Good. still think it's a zero sometimes. What happens is then you will turn it back. So.
Okay, so it's kind of like, right? Yeah.
Right. Yes. Was it front? Why the print is will print, you know, put the bill to set down and set down. I mean, it's just a little thing, but you know. Well, there's a fire here, the fire department shows up. Actually, they saw pretty regularly on campus, but even if you have a senior living facility over here, but fire come on.
No, it's fine. I had teachers stay up there with me. They're like, yeah, the building burns down. At least I don't have to work anymore. They really didn't want their job, so I was like, oh, yeah.
I don't want this burn. I can't. I mean, this is a pretty solid stone building. It's not. Where people online have been listening to this. All right. All right. Okay, fire drill is over. We are going to try to use NetBeans to try out some of this code here. And so, again, you're welcome to try out this code too, or just watch and see how it works. You don't have to turn anything in and do anything like that. So there's no pressure. But again, sometimes it's good to go through the exercise of typing this stuff in, you know, depending on how it helps you remember things. So that's what you have to kind of decide for this. So I'm going to start a new program. And again, I could reuse an old one, but sometimes I like to do new ones so I can go back and look at these. I don't go back and look at that. I just say that you might want to create a new one so that you can go back and look at them. So I'm going to create a new project. Ant is still selected. That's good. I'm going to call this Unit 2 Sandbox. Sometimes I just call these things sandbox because they're just a little area to play or work with for things. So you can more easily follow it on screen. I'm going to delete some of these comments here and zoom in a little bit more here. Okay. So remember how we did print from last year? Last class, system.out.println. Hello. And then a semicolon at the end. So then we can run that and it'll print it out down at the bottom here. So let's talk about variables. And again, I'm just going to kind of follow along with these variables in this code over here. There. Oh, we thought we lost you, Dylan. We were very worried. We were out sending out troops or, people, firefighters. That's who we should be saying. Firefighters to find you there. It's not, you might be trapped inside, you guys probably don't even remember last. Okay, well, we'll go back to this. Okay, you're glad you came. Okay, we're going to declare some different variables. Let's do our normal ones. We'll do an integer, and we'll do a number of planets. Now you can do that number of planets, declare an integer that way. But again, we'll often use camel case. So we'll start number of and then planets. Yep. Why is it so cold in here? Because we're running the air conditioning. So this lab is one of the few labs in the whole school that is run on air conditioning. Most of the building is not. So it's really nice in the summer and when it's hot outside, this will be cool, unlike the rest of the building there. But the air conditioning, the thermostats here do not, I don't know what thermostats run this, but that thermostat does not seem to run the air conditioning there. So you'll feel, see, these are the air conditioning beds, and you have one right up there. This is the air conditioning bed, and it is blowing right down on us. So just be aware of that. Now, it does work better if we close this door and that door, because this whole wing, all the labs are supposed to be air conditioned. So I'll try to start closing some of these doors on there. So, because then it'll cool off in here and trigger some, well, actually, I think the thermostat somewhere in the hallway. So, okay. Right. Yeah, you're getting cold there too. So I just say you might want to wear a sweater or something to class. Just right. So and in a while, in another 2 weeks, the heat will start going on, and then we'll be running both air conditioning and heat at the same time for a while. I don't understand. I'm just a computer person. Yeah. So okay. Okay. So number of planets or number of planets, we can write it either way. Declare this variable. Now it is still giving us a warning here, but it is underlining this. So notice these two different warnings. This just yellow dot with a little orange triangle is a warning. So it'll still work. It's just suggesting something. But in this case, suggesting you declare a variable, but you're never using it. But this with the red underline, not the orange underline, is an error here. And you see this the yellow light bulb with the red exclamation point next to it. And what that means, if we try to run it, it won't even run here. We can say run anyway, and it'll give us an error there, won't even compile. So again, you can ignore these sorts of errors. Often you should maybe pay attention, but it'll still run. So what this means, I'm missing a semicolon there. So, okay. So I've declared those two variables. Now, if I want to use those, I can say number of planets equals 8 and store a number there. So that's how I declare a variable there. Now, again, these are two different variables. Oops. For this stuff. And I can print out these. I can do my system that print line. And I can print out like number of planets. And print out that a variable prints out the value 8 here. But now that is different than if I did it in all lowercase, and actually one of them doesn't have an S and one has an S. There, that would print out, oops, it's back over here. That'll print out 9 here. So again, this is case sensitive here. For us, so we have to just remember what case we're using. And it's very particular about how we spell it. If we put an S here, we have to put an S here, there. So you've got to be very particular about your spelling and your use of it has to match exactly. So now I'm not going to want both of these. So I'm going to delete one here. Now I can just delete this here. So I could just click on it, delete. Or I can just do, I'm just going to go back here and reset this one there. I can also just comment them out. So sometimes if I have code and I'm not that interested in, I don't want it to run anymore, I'm just going to do dash dash in front of it, and that'll put it as a comment. Anything after a dash or slash slash is ignored here. So So again, sometimes you can do that. In fact, we'll learn there's most compilers have keys where I can highlight a whole section of my code, hit some key. I always think it's control slash. Yeah, it is control slash here. Hit control slash, it'll comment that whole section out there. So again, if you're working on and doing that, some people find that really helpful is to highlight code, hit control slash to comment it all out temporarily, work on it and hit control slash again and uncomment it out. So sometimes it will do that when I'm just practicing stuff or working in a sandbox. Okay, so that's my integer there. Let's do a floating point, a decimal number. So again, I can do double grade point average. So I could just declare it like that, or I could set it equal to a variable right away, 3.45 for this. In fact, so you can declare a variable and set it equal to some initial value right away if you want for this. Now, again, there's this warning, and you can actually go over here and see what the warning is. Variable grade point average is never read. So we're setting it, but we're never printing it out or anything like that. So again, maybe I should print it out to make the computer happy. One of our goals in life is just to make the computer happy there. So we're going to make the computer happy. It's just, oh, there's a warning. It's worried about that. So I'm going to do my system.out.println grade point. And one thing that's nice about this is once you type in a variable and it matches something, it'll highlight it later on or where else it appears in the code. So that makes you realize, oh, that I did spell it correctly and I did type it in that way for that. Now, generally, programmers now use pretty long variable names because most of these editors will automatically fill them in for us. That's one of the problems with this IDE is it doesn't. So when I start typing like GRADE, it is not, almost every other editor I know will automatically put grade point average in here and I can just hit enter there. This one, for some reason, doesn't. So you just have to get used to it. So what I tend to do is use longer names, but not maybe really long names here. So maybe I'll shorten this a little bit so it's a little easier to type. I could use GPA, I guess, but again, I want to try to use that. So just keep in mind that we'll tend to suggest you use longer names rather than like, I don't want to use just like G here and G there. Because what is G? How do you understand? And when you have 20 variables, eventually understanding which one is which is not very helpful unless you have a little longer name there. So, okay, so let's see if I can print out. So now if I run this, it just prints out like 8 and 3.45. What if I wanted to say something with that? So can we say GPA is, let's see if we can do that. How do we print out some words and then and then a number after that. So we can try that. So we can use a plus symbol in here for that. So we can say GPA is, and say like here, we could say number of planets is or equals, or let's just say is. I don't want to confuse the equals there, and then just do a plus. So I can print out multiple things in my print line statement, and then I can have that. I can put them together with pluses here. Okay, questions on numbers and stuff like that? We'll have to do operators of numbers in just a little bit, but we'll just do the variables here. Similarly, let's try Booleans and try to do a Boolean. So a Boolean variable, so you can declare a variable like is cold or something like that. Often it'll you know, like what do you use Boolean? So like in my mobile apps class right now, we're doing a tip calculator, and one of the things we have is a little checkbox to say, do you have outstanding service or not? And that will dictate how big of a tip you want to give there. And so that box, that checkbox is either checked or not. And so we store that result as a Boolean. Is it checked or is it not checked there? So we can check if it's checked. We can check if it's checked and do something if it's checked. So if it's checked, then we'll use a higher percent for the tip than if it's not checked there. So again, sometimes you'll use, and again, you'll use these a lot as you get into a more advanced program. In this class, we won't use Booleans that much. When we get to if-then statements and loops, we'll start seeing them, but we won't use them as much as in some of the advanced classes there. So we just declare, we can declare Boolean, and then we can set equal to true or false. And true and false are reserved words here. You can see they're in blue here. So, what happens if we print this out? I don't know in Java what happens if you print this out, to tell you the truth. I think it'll print out true. Let's try that. Yeah, prints out true. Some languages print out 1 for true and 0 for false. Some languages print out true or false. Some languages you can't print out Boolean. So I can never remember which language we're in right now and how it works. Okay. Let's do we'll just mention characters. We'll talk about these more later. So I'll just mention there is a char type, char, and you can store a single letter there, and it is in single quotes. But we will generally use strings, and we can have a string like name. Here we're going to call it username to match the example Chris has. For this. So now here's a question. Why is that underlined, and why didn't my cursor go back to the beginning of the line here? So I hit enter, it put a red underline in it and only put the cursor here. Why do you think? A couple hints. Well, one of the reasons is that if you continue a statement, it'll automatically indent. So it still thinks I'm on the previous statement here, and it's underlining. And if I go over here, it'll say semicolon expected as my error up there. So that all indicates that I didn't remember my semicolon. And then I go all the way back, so that's good. Okay, and again, now I can print out my string here, just like any other print statement for that. So this is what this variable example is kind of walking you through, setting up different things, storing values in them for this. It it doesn't remember things. So if we change the GPA, so I'm going to grab this. Now, if I want to use this variable again here, I want to reset grade point average. It's giving me an error, and the error is that the variable grade point average is already defined. So I can't, when I say the type, it sets it up in memory and creates memory for it of that type and gets it all ready. Now that's already in memory, I don't have to say its type again. So if I want to use this variable again, I just say the variable name here. So grade point average is equal to, and let's say my grade point average dropped to 3.11. So I can use that. Now, when I print this off, what will it print off, this one or this one? And you just have to remember that your code runs sequentially here. So it's always going to start at the top, and it'll do this line. It'll skip over the comments. It'll do this line. It'll do this line. It'll do this line. It'll do this line. It'll set up grade point average as a variable, and it'll store 3.45 in it there. And again, let me just grab this board. I think it's good to have just a little mental picture of this there. So what it's doing is it is creating a variable that's going to hold a double, and it's calling it grade point average. What I called it? Yeah. And it's wanting us to store something in there, and we're storing a value. We're storing 3.45 in there. And then when we print it out here, when we go print GPA is, it's looking at this variable and it's going, oh, grade point average is 3.45, prints that out there. Okay, now it'll go on to the next line, creates an is cold variable. Boolean variables are very small out here, so it'll create, a little variable is cold. And obviously we are cold today, so that is going to be true. We're going to store true in there. Print that out. Stores an initial, stores username. Usernames are big, long strings. They can be as long as you want. And that's what I'm saying, is that these variables are different types, and in memory, there are different sizes. That's why you can't store a string in another inside a double or something like that. They're actually different size boxes and memory sort of stuff. And the way they're organized is different there. But now we get down here and we get grade point averages 3.11. So now we're taking this, we're overwriting it with 3.11. And so now, in the second time when we ask to print out the GPA, it's going to print out 3.11. So it prints 3.45 at the top at first time, and then 3.11 the second time, because again, it's just one variable, and we're overwriting it with different values here. So again, I think it's nice to have this kind of mental picture of variables, and I think some of these textbooks will show those. Forget which one does. One of them does. I guess, yeah, this one is trying to show, like, here's a small binary, here's a score, an integer, and here's a bigger variable spot out there. Yeah, let's talk a little bit about mathematical operators then. Well, questions on any of this stuff? Declaring variables, using variables? Any questions? Questions about the thermostat, the heat, where to get water, where the rest, you can ask anything at this point. We're good. Yeah. All right. Okay. Let's talk a little bit about calculations here. I'm going to jump into this one and talk a little bit about some of these calculations. Here we're just doing printouts of stuff. And then I think, maybe it's the next. Yeah, 1.4 is expressions. We're going to talk about the assignment statement where we're going to say a variable name on the left equals and an expression on the right. And the computer will evaluate this expression and store it in the variable value here. Now, this is different than a mathematical equation. In a mathematical equation, you could write it either way. In this, you can only write it one way here. You have to have a single variable on the left side, then an equal sign, and then an expression on the right-hand side here. So, for example, if I want, let's say we lost a planet here. So we have number of planets here. And now we're going to lose a planet. I've been watching the new season of Star Trek, Strange New Worlds. I like that series. It's very retro, and I'm a very retro person, apparently. So, I'm thinking, oh yeah, you could lose a planet. That's something you could do. So, number of planets equals, so we could say 8 minus 1 for this to say is going to be less for this. So again, we have our variable, our assignment operator, and then this. Now, you're used to equals being a math equals thing. This is not the same. This is an assignment operator there. We have a different a thing for checking if two things are equal there. We'll eventually ask if, like, number of planets equals 9 or something like that. So when we want to check if two things are equivalent to each other, we'll use equals there. Okay, but that's in the future. So this is an assignment thing. And again, you can't say it the other way around. I can't say 8 minus 1 equals the number of planets. It is going to try to store the number of planets in a variable called 8 minus 1. It's not going to work. So that is not happy. So we have to do it this way. So now if we do this, I'm just going to mention, I remember I mentioned you can comment out. I'm just going to comment out the rest of this stuff for now. Okay, so now it says the number of planets is 7 because 8 minus 1 is 7. And it's going to print off that for this. So it's we can do that. We can do math here. I mean, it's just a calculator, So you can do minus, you can do plus here. You can do multiply. So let's say we're going to have twice as many planets or 3 times as many planets as we go here. You can do division. Let's try 8 divided by 3. What is 8 divided by 3? So how many times? 8 goes into 3 twice. That's 6, right? And we have 2 remaining, so 6.666, right? 2.666, right? So that's what it should print out. What is it going to print out? It's going to print out 2 here. Why is it printing out 2? Because this is an integer. This is an integer and this is an integer. So it is only working with integers here. And it says integer division for this. It does like long division where it says, like, I don't care, remember it. 8 divided by 3 goes in twice, 6, and the remainder is 2. So this is the remainder. And this is the divisor or the result, the value there. So it's going to get that one up there for that. So Let's try a different one. Let's try 9 divided by 5. Here. Yep.
Don't. Isn't it over?
Oh,
I'm just like,
yes. Class over. Yes, we should probably stop. That's a very good question. So I had so much to cover, and fire alarm threw my timing all off. You don't need to go to your next class. Sophie's next class is here anyway. Everyone can just stay, right? There's a nice class here. Okay, go home.